and John also. Becky, if you're ready to go, over to you and jump in. Oh, brilliant.
All right, can everyone hear me okay?
I can hear you.
I was trying to stay muted for a second there. I'm set up in our basement and my daughter just flushed the toilet and it's right above me. I'm like, oh, that's great timing, honey, great timing. The wonders of working from home, right?
Indeed.
So if you hear any strange sounds, I apologize. I have one kid who's attending school in person and one who doesn't do so well with mask wearing, so she's home. So I warned her not to interrupt, but if you hear anything, I apologize. So
no worries, no worries.
All right. So I've actually given presentations on requirements probably at about 5 different NI weeks now. I don't know if anyone's actually heard me speak about them there. I actually don't like requirements at all, which is kind of funny that I'm always asked to give the presentation on it. It's one of my least favorite things of my job, but it needs to be done, right? So for those of you who haven't met me before, I'm a certified LabVIEW architect and LabVIEW champion. I work for Conrad Technologies USA, which prior to the acquisition 3 years ago, I think it was, we were VI Engineering. And I started at VI Engineering back in 2013. So my history with LabVIEW real quick is kind of fun. I actually started working with LabVIEW 6 in 1999 as an intern at General Motors at GM. I worked on the EV1, which was like the world's first electric car forever ago. And we used LabVIEW for testing a bunch of different things with the battery systems. And so that's where I started out with LabVIEW. After college, I went and worked at National Instruments for a few years, got married, had a few kids, stayed at home, decided I was the worst ever stay-at-home mom, and then went back to work. So I've done a little bit of everything. I kind of want to talk about why requirements, why it's important to write your own, why what the customer gives you is never enough. We'll go into some official definitions, verification versus validation, because I feel like those terms get tossed around a lot and interchanged, and they don't quite mean the same thing. And then I have an interactive part, and you guys can do it in the chat, or we can do it in person and announce it. But we kind of have some good versus bad requirements. And the funny part about these is every single one of the requirements I'm going to show you are real ones that were either suggested by a customer or used in one of our projects. And so it's kind of a fun thing to look at some of the things people ask for. How to manage your requirements, and then finally traceability. So it is not enough to do your best. You must first know what to do and then do your best. This is kind of a big quote I work with some of our younger engineers on, because especially when I'm working with our interns they're so excited, they want to get straight into LabVIEW. I give them a small project to do, go make a card game in LabVIEW. And they just dive right in. They open LabVIEW and they start building, which is awesome. And I'm excited for that. But then they might miss things up front. So first you got to know what you're doing, ask the right questions so that you're not going down the wrong path. And that's one of the reasons I actually like this quote and have left this in here for, I think, every requirements presentation. So why are they so important? Why do these always come up? Well, you can't test something if it's undefined. Your requirements are where your overall testability artifacts are born. It's where everything starts. If you don't have them, you don't know what you're doing. And so if you don't have requirements, you don't know the important things. You might be focusing on the unimportant things. The big things to me are we're separating the wants from the needs, because those are two different things. And then it helps prevent scope creep. I don't know if that's like a term in the UK, but when a customer's like, oh yeah, great, it does A, B, and C, but I also now need it to do, 1, 2, and 3. And you're like, oh man, like I didn't know how to do all this extra stuff. Whereas if you had a set of requirements that both parties agreed on, you'd have a way to ask for more money or an interjection there. Well, we agreed on this and that's what I delivered. So now you need to pay me more to do the other things you want, right? So for especially a self-run business person, that's kind of important. And I love these little comics, but it's kind of like in CS, it can be hard to explain the difference between the easy and the virtually impossible. It's kind of like when a user takes a photo, the app should check whether they're in a national park. Sure, easy, give me a few hours, and check whether it's a bird. I'll need a research team in 5 years. So kind of a fun little comic in there. One of the biggest things I hear when we're meeting with customers and they kind of question why we're asking or wasting our time writing requirements when they gave me requirements. They're like, we just gave you our requirements document. You don't need to waste your time rewriting it or doing whatever it is you're trying to do. Well, that's what I call customer requirements. And your official system requirements are not the same. The customer a lot of times will give you like product specifications and they're like, the product should do this. I need you to test it and make sure it does this. Well, that's great. They might even give you some test system specifications. I want to use PXI. I want to use this card. And that's helpful too. And they might give you some other design constraints. Maybe they want to use Linux versus Windows or whatever. Bunch of extra information you don't care about. But it's hard to track what you actually have to do when you have a bunch of non-cohesive documents kind of thrown at you. So creating your own system requirements document allows you to better understand the project itself. The big thing here, though, is consistency between projects. So you know what you're doing on this project can kind of relate back to, wait, I did this before. I bet I can reuse some of this other code. You can kind of think of that. And a really big one, especially in regulated industries, is being able to tie back directly to acceptance test procedures for verification, for traceability. And so in the same aspect, system requirements are not the same as a system specification. So a system specification includes the system requirements, design constraints, and in the system requirements themselves, you probably have hardware and software requirements and different constraints. And while at Conrad VI, I've worked with almost every industry. I've done stuff with consumer electronics, automotive, mil-aero, medical, and it's really interesting seeing what some of these big companies do. I found the more regulated industries actually have separate formal documents for everything I'm showing on this screen. They have a separate system requirement that references a hardware requirements document, that references a software requirements document, and there's all this like giant nest of documents. At Conrad, I'm not going to lie, we kind of cheat and we call it our system specification, but realistically, it's usually just a system requirements document. And depending on what the customer is asking us to do, we might not have all the pieces that are in a system specification. So we call it that, but I don't necessarily know that we actually do the full thing. And I'm sure you guys probably all do something similar. One of the big things here, though, I want to mention too, before I forget, is that requirements should always answer the question, like once we get to this part, what is the system doing, not how is the system doing it? That's actually more of a design constraint. So this is a big one. Change is not the enemy for you. Requirements can and will change. What the problem is uncontrolled and unmanaged change. And we're going to talk about that a little bit later, but that's just something else to keep in mind, that once you complete these documents here, they're not set in stone. They should never be set in stone. A lot of times the product you're testing is being developed at the same time you're developing the test system for it. So things will change. So let's start by looking at requirements per IEEE. So this is kind of a specification. It's mostly for software requirements. Have you guys seen this list before? Anyone? Kind of a fun list. I don't know how much fun it is, but we've got a list on here for like, it should be correct, unambiguous, complete, consistent, ranked, verifiable, modifiable, traceable. Most of these are pretty self-explanatory. Correct. Of course, you're going to try to make your requirements document as correct as you can. You're going to do the best. But there's a few of these that I feel like people take to heart a little bit too seriously. Well, I can never finish these requirements. I don't have enough information. I can't make them complete, so I'm not even going to bother doing it. So I kind of want to cover complete. I want to talk a little bit about that, a little bit about unambiguous, because that can be a fun one to look at, and then verifiable. And so when I say requirements must be complete, does that mean I can't have any to be determined? Can I, what if I don't know the answer right now? Should I just skip writing requirements? The answer to that's no. Most of the time when I start writing requirements, almost every value or anything in there is TBD or TBR, to be determined or to be resolved. The key here is to put a comment in or mark it like, why don't we know yet? Well, we don't have enough details on the UUT. What must be done to eliminate it? Who's responsible is the big one, because if you get to the end of the project and you're like, well, who was supposed to figure this out? No one ever did. And then when should it be eliminated by? And this should be stuff that you all agree on with your customer. Like, yep, we don't know the answers to this right now. This is the general plan, things we want to accomplish. So let's move forward, but we're putting in a TBR just for the future. The next one is unambiguous. Depending on the customer, the wording of requirements can be very important. You guys have probably seen this before, the shall, should, will, may. Shall denotes a mandatory requirement. Departure from it is not permissible without formal agreement typically. Should denotes a recommendation or advice. Will is a provision or a service. Basically, how am I going to meet this requirement? May is permissible practice, action, and it does not express a requirement at all. So the key here, though, is that only shalls need to be verified. So when you're writing your requirements document, if you have everything as shall, that means you need to verify it. You don't always need to have everything as shalls. Should or wills or mays are also acceptable. You just need to make sure your customer also understands up front that the only things you're going to prove out during verification is the shalls. Now, INCOSE is another standards body out there. It's the International Council of Systems Engineering, and they have their own requirements working group. It was developed to write the requirements, get the best practices, biannual updates, and I kind of have a quick standard or note in here. So the INCOSE stuff is not really like an official standard, but it's updated more frequently and focused more on systems or not software. And I'm kind of curious if you guys want to write in the chat, do either of you, anyone follow like INCOSE versus IEEE requirements? I guess like recommendations, or is it just kind of you do your own thing or copy something somebody else in your company did? Because we've studied both of these and we kind of have our own internal requirements documents based on both. Because as I continue on here, I'm going to kind of go over what INCOSE says about requirements. They say that the characteristics, that requirement statements need to be necessary, appropriate, unambiguous, complete, singular, feasible, verifiable, correct, and conforming. So a lot of these are very similar to what IEEE already said, right? The one difference I like about what INCOSE does versus IEEE is they break it up into, and I made it bold, requirement statements have characteristics, but they also say sets of requirements have characteristics. So they kind of take a more holistic approach. We're not just looking at like just hardware or just software. They say that each statement has to be a certain way, and then you have groups of them that should also be complete, consistent, feasible, etc. And so they have a little bit more official writing rules. And I'm not going to go into theirs. You could go to their website and they have a bunch of details. It's all free to look at, but they have like precision, concretion, no ambiguity, singularity. And so I have a few examples of these. I'm going to look at in particular singularity and quantifiers. So the first one is quantifiers. The unacceptable example they give is the operation logger shall record any warning messages produced by the system. And pretty much the one that throws this off and makes it completely unacceptable is any. Any makes it very vague. Well, what do you consider a warning message? Is what I consider a warning message the same thing that Chris considers a warning message? Maybe, I don't know, right? It's a very vague thing. So you need to quantify exactly what you're doing. So their replacement, their acceptable one there is the operation logger shall record each warning message. And notice they kind of put it there like as its own variable, if you will, produced by the system. And so warning message itself now needs to be defined somewhere else so it's clear to everybody what is a warning message, what is getting logged. The next one is singularity. So the unacceptable version is the control system shall close valves A and B within 5 seconds of the temperature exceeding 95 degrees C and within 2 seconds of each other. That's a really long run-on sentence, and it's not clear at all, and it's kind of confusing as to what's going on. And so they're saying it's just like you kind of have to draw your own chart in your head, and is it going to look exactly like what you mean you're trying to do? And so their acceptable version is when the product temperature exceeds 95 degrees, the control system shall log input valves as specified in a timing diagram. And they don't show it here, but the general idea here is don't just feel like you have to have only words in your requirements documents. It's okay to have tables or flowcharts or things like that to actually show what is going on and what's going to happen. I mean, we're all LabVIEW developers. Isn't a picture worth way more than these words? We all avoided text for some reason, right? That's my opinion. So my requirements are typically full of all kinds of random diagrams and things in there just to try to get my point across to the customer. And this is kind of a fun thing that I didn't fully understand myself, I'd say, till about 5 years ago. And so verification and validation are not the same. It's important to note that requirements need to be verified, but not validated. So if you're following in any regulated industry, requirements need verified. That's the key. And so there's a difference between the two. One of them answers the question, did we build the system right? Versus, did we build the right system? Those are two different questions that are both important. And so I have an example to kind of go along here, and I have a requirement. I must have been really hungry when I made these slides a few years ago, but I want to bake a sweet single serving dessert with a hint of chocolate. So I'm going to say, all right, that's a good requirement. You know what I'm going to deliver to my family tonight? I'm going to deliver a cookie. Wait, what's that called? Is that a biscuit? Is that what it is? Okay, biscuit. I always forget that. I know like my American English is not the best. So we've got a cookie. Well, is my cookie sweet? Yeah, I'd say so, yeah, if I made it myself. Is it single serving? I usually prefer more than one cookie, but I guess that could be for one person, depending on how hungry they are and how big the cookie is. Is it a dessert? Most people would agree that it is a dessert. And does it have a hint of chocolate? Well, it's not fully chocolate, so sure, why not, right? Did I meet all of my requirements? Yes. So what I've just gone through right now is verification. I have fully met every requirement that I set out there. Now, I go to the customer though, and this is not what they wanted. They didn't want a cookie. They wanted a vanilla cupcake with chocolate frosting. So how on earth could I have prevented this from happening? What if before I ever got out all my ingredients, before I ever baked my cookie, I showed them a picture? Is this what you want? Is this good enough? Well, what that is that's like design. That's validation. So that's design validation. So that's asking like, this is what I'm doing. This is my plan. And that's different than requirements. Because again, with verification, with the cookie, I met the requirements, but that's not really what the customer wanted. So just because you can verify your requirements, you still might not have a happy customer. You need to do both. And so this V diagram is pretty popular and people see it a lot. And to me, this V diagram is still applicable with agile style development. It's just that it happens kind of more in an iterative over and over again manner. But you have requirements, you build a design against those requirements, you share that design with the customer for validation at the same time as you're going to development, right? You can kind of take these two paths at the same time. And then you need to verify when you're all done. The customer agreed that the design was good. We met all the requirements. Everything's happy. So realistically, you should be planning your verification though, while you're writing the requirements. Because as I said earlier, requirements are what need verified and only the shalls need verified. So if you write a requirement statement and there's no way that you can verify it, that's bad. That's a bad requirement statement. That's the biggest thing for you. And also, don't forget, the whole process is iterative. If the requirements change, the verification changes. So even though this looks like this is for the whole project, when we do projects, we tend to break it up into smaller pieces. Maybe we have a module that focuses on analog input. And so we have requirements for that. We have design for that. We share our plan with the customer. We share what cards and stuff we're doing, you know, and it's kind of a cycle for that. Then we repeat it for another component in the system. So what are the difference between the verification and validation methods? The left oval here is verification methods. The right oval is validation methods. And the stuff in the middle, the dashed line, is kind of test. And so for verification, you can inspect something. You said you were going to build a system that has a touchscreen monitor. You can kind of see, yep, hey, it's a touchscreen, it responds. That's inspection, right? Analysis, you can run a bunch of tests and actually like analyze the results. You can demonstrate the system running. Those are all verification methods. Validation methods for designs are things like prototypes, UML, CAD models, design documents, those types of things. And then in the middle, it kind of all starts to blend together where it's partially validation, partially verification. So going back to our original questions, did we build the system right? When we're answering that question, that's verification. Did we build the right system is validation. Does that make sense? It's kind of a strange thing to think about, but I find that breaking it out this way seems to make those two topics a little bit clearer. So now is the test. This is the interactive portion. You guys ready? Good versus bad requirements. The first one up. The test software shall not crash within 1 year of use. You can give a thumbs up or thumbs down. It has very good intentions. I mean, the customer wants stable software. I want stable software myself. You can test this too. The test software shall not crash within 1 year of use. I got a couple bads on the list there. A couple more bads popping up. Yep, this is not a good one. It's not really verifiable because, and it's very ambiguous. What does crash mean? Does crash mean no memory leaks? Does crash mean it just runs 24 hours a day for 365 days? That's very ambiguous as to what a crash is. But my other favorite part is you could kind of verify this, but your test plan would take a full year to execute. And then if you fail that test plan, you need to make a software change and take another full year to give it a try. Could you imagine trying to make money on a product or something like that? That would be crazy. Like, oh, I'm sorry, I had to fix a bug. Give me a year to test it. Then you get the new one. I mean, that's definitely not how Microsoft works. I get updates every week. So, all right, next one up. The system shall display everything the operator needs to know on the user interface. This one's kind of that's true. You could end up validating the operating system for the other one. So everything the operator needs to know on the user interface. This is a kind of an obvious one. It's bad. It's very ambiguous. How do I need to know what the operator needs to know? Like, that needs to be broken out more. So a valid one would be the system shall display the current control voltage set point. At this point, I will often put in a mock user interface in my requirements document saying, this is kind of the plan. That's more of a validation thing, but it also shows when I say current control voltage set point, I'm thinking in my head maybe just a numeric control when the customer's thinking a slider. And I want to clear that up right away. I always create fake UIs, even though they might not even look nice, but just showing little objects like that. So they're like, oh yeah, I want the slider, or no, I want to be able to just type in a value. Those are the types of things that could be easily cleared up. And that's a good point in here is I would say present, not current, because current and voltage might get confusing. It's a very valid point. The system shall wait 3 seconds. This one's a little tricky. The system shall wait 3 seconds. Are we thinking good? Are we thinking bad? This one's kind of a tricky one. This is bad for quite a few reasons. Some of you are listing them in there. It's bad because, like, from what? From what condition? When is it waiting? But the other important thing here is who has a watch that is accurate to 3.00000 seconds? Can you realistically try to make it exactly 3 seconds? So at least 3 seconds is a better way someone has in here. A lot of times you might put something like plus or minus. So you give yourself a little bit of a threshold. Because if it's really important for whatever reason to send a command to a UUT and wait about 3 seconds to get a response back before a timeout, you might want to say the system shall wait 3 plus or minus 0.1 seconds or whatever's acceptable for the customer, you know, before deciding that this is a timeout condition or whatever. So this is still very vague. The system shall wait seconds, but even this is better than just the 3 seconds. The system shall read the UUT serial number from a barcode. This one's been up for debate. I actually usually say this one's not bad. It shall read the UUT serial number from a barcode. I've had people say, well, you're not specifying the type of barcode. And that's true. Oops, I'm jumping ahead there. That's true. I'm not saying, you know, is this a 2D barcode or what are we looking at here? But that's more of the implementation. That's more design. That's not so much like, what's the actual requirement? I have to read a serial number with a barcode. Great. Can I prove that? Can I verify that in the end? Yes. How I go about doing that, I probably don't need to get into the details in here unless the customer requests it. So this is where it depends on your customer and yourself, how much time you have to spend on requirements versus where do you draw the line in your details. Set the power supply to 5 volts, 10 volts, 20 volts, and ensure the power supply actually is outputting the specified value. The test software shall set the power supply to 5 volts. The test software shall measure AI01. The test software shall fail if AI01 is less than 5. The test software will repeat the previous steps for power supply levels 5, 10, and 20 volts. And these are a little bit hard too to think because they're a little bit out of context because you're missing their other requirements and stuff around them. But this is an actual thing from a customer requirements document they gave us. That is a lot of requirements in one. They kind of have 1-1, 1-2, 1-3, 1-4. Is there a better way to show this information in general? I mentioned it earlier. You could actually use like a table, right? Settling times are needed. That's good. Here's another one that a lot of people don't catch. If I read on AI01 10,000 volts, the system passes. Do you think that's probably what they want? They're like missing information. So there's a bunch that's kind of wrong with this one. I think the intent here is good, and they're going down the right path of breaking it up and then, oh, repeat these steps because I don't want to rewrite them 20 times. But there's a lot that can go wrong, right? It'd be really good to have a table and say a better requirement of like set a power supply to the voltage specified in the first column of the table below. Make a measurement on this channel. Ensure that it's this within so many seconds and within percentage of that voltage or whatever it is, right? So there's better ways to improve this. The test system shall contain a PXI 4070 for voltage measurements. Got a thumbs up. People are thinking this one's good. Is this really a requirement though? This is more of a permissible action. So I think the word shall throws us off. This is more of a design constraint. Like the customer says, hey, I want you to use a 4070 and I have no problem using that. But do I really want to have a shall and have to prove out that it's a 4070 in the system? This is something we usually put in the back end of our requirements, kind of as an appendix, design constraints. And it's things like the system should have, or things like that, that I don't have to prove, but it's to keep in mind as I'm going down the design path that that's what I'm planning to do. But how do I prove it's a 4070? I mean, I could look at it, I guess, but is it worth time for all of that stuff? Is that needed? So yeah, it's a constraint, not really a requirement. So the system shall create a test record in a database for each UUT tested. The system shall record the test socket to the test record. The system shall record the test date time to the test record. The system shall record the operator name to the test record. The system shall record the overall test result to the test record. So basically, the context behind this a little bit is there's a database, and in the database, there's a test record, it says right there, and there's 4 data points that need recorded there. So people are thinking about this one. This one's pretty good. It could be required by, and some of it could be the naming here. It could be covered by one requirement, less testing. But realistically, you could run your software as a demonstration, open the database, and ensure that those fields were all populated as expected. So there's a single test record, which I think is kind of like a database. And that's the idea. So this one, I think a table might be more helpful too versus the text, but the general idea is there. Or it could be like the system shall create a test record in a database for each UUT tested and record the following parameters and then list the parameters. I would preferably write it that way, but this was in one of our requirements from a customer, and I think we left this one as is. The test software shall be written in LabVIEW 2018. So this is very similar to the PXI one. So again, on the surface, it's kind of fine, but realistically, it's more of a design constraint. This is an interesting one though. So having a shall in there, how do you go about proving that the test software was written in LabVIEW 2018 when you give the customer an executable? I mean, it's going to be kind of crazy. Like, and is it LabVIEW 2018 F1 service pack? Like it gets really crazy to try to prove out, but that shall is kind of crazy. So if the customer is very insistent that design constraints be put in requirements, just beware of the wording. So a lot of times if a customer is like, well, no, I really want you to put that in there. That's a requirement that you use LabVIEW 2018, and that's fine. We'll include it. But again, it's more implementation. It's a design constraint, and watch the words. Use may if that's the case, because you definitely don't want to try to prove that one out. And in a regulated industry, they will watch and say, all these shalls need verified. How did you not verify that this is LabVIEW 2018? And some customers would be okay with, here's the source, it opens in 2018. Others might not. So it all depends on who you're dealing with. The system must have a user-friendly operator interface. I think this one's pretty obviously not that great, right? what's user-friendly to me might not be user-friendly to you. It's very subjective. This is one of my favorite ones ever. This was a real requirement from a customer. The test operator shall not get bored. The customer literally had issues with operators not paying attention and like falling asleep while the test system was operating. So they wanted to make sure they were engaged with the test software. But it's kind of hilarious because it's like, this is so subjective. Like, do we randomly pop up dialogues and have them play a game? Like, what? That's kind of the funny part. We're like, all right, well, we'll do our best to make sure it looks nice and they don't fall asleep, but I can't guarantee. Maybe you should hire a new employee. So that one, of course, is bad. So that's just kind of a fun break in the middle there. We'll move on to managing requirements. So thus far, we've talked about requirements and kind of, you know, what they are, what they should look like, but how do you actually manage them? So requirements management is like a whole field of itself. It's all about how do you document the requirements? How do you manage them? How do you archive them? How do you bring them back? There's a whole life cycle to them. The key here is you need to have commitment from stakeholders along the way. And I love some of these comics, but like, how do the stakeholders think requirement gathering works versus how requirement gathering really works? How many times are you halfway through a project or all the way to the end and the customer's like, well, that's a requirement. Why isn't the system doing that? It's like, well, you've agreed upon all these other things. You can't change your mind partway through. So it's important to document and have a process of it and manage your requirements so that you don't get to that point of contention towards the end, because change is allowed to happen again. It's just that customers need to, you know, you've just spent 6 months of your life creating this test system that apparently doesn't work for them because they forgot to tell you one thing. That's not your fault. You know, everyone needs to know it's a teamwork, right? We have to work together to get everything happy. So next up is a clear understanding as they evolve. And I love this one. So the client kept changing the requirements on a daily basis. So we froze them until the next release. I've been on a multi-year project right now with Conrad. It's going on 2 years for a in-vehicle data logger, and it's being used with multiple customers. And it's really interesting seeing how our requirements have evolved. And we don't even have real requirements from the customer. So a lot of them are self-made requirements. And then we're like, wow, that was a really bad idea a year later. So again, keep in mind that change is okay. It's managing the change. We've gone through a number of different tool chains. We've actually used Teams to try to manage some of our requirements, like within Planner, not a very good idea. We've got Confluence and Jira. We've got a bunch of different tools and there's tons of stuff. And none of them are really the best, I'm going to be honest. And we've got Word documents floating out there. So the tools that most people think of are these. So a Word document, maybe Excel, PDFs, and those are okay. Because to me, honestly, the only bad requirements management tools are the ones that are not used at all or that are not used consistently. So in the US, we're a little bit different than Germany from our workflow standpoint, but every project has a technical lead, multiple engineers, and a project manager. And the technical lead is responsible for the requirements as well as the major design points for everything. And we have a template in Microsoft Word. Again, it's not pretty, it's not the best thing, but we're using like styles, you know, within Microsoft Word at the header. And then we can do things like parse our document to pull the styles in. And again, it's not fun, but we've got a lot of stuff built up from previous years. And some of our customers have their own tools in place. So we need to be able to take these requirements and get them to them in a separate way. So not the best, but they do work. So I do have a note in here. So try to avoid abusing documents like this, like PDF, Word, or even Excel for requirements. One of the things to watch out for is multiple versions. There's not a lot of consistency unless you build in templates like we have. Tracking changes is really hard to do. It's a very manual process. This whole thing is manual. If I go in and change requirements, I need to write that down. And even if I have the document in SVN or Git, I still have to go back and be like, oh, what did I change between the two versions? Write it down. So we've done a bunch of strange things. Like when we delete a requirement, because you can also delete them, we actually leave it in the requirements document, but change the text color to light gray and put strike through it. So that way later on for traceability, that number doesn't get reused and nobody questions, why did you go from requirement 31-1001 to 31-1009? What happened to the 7 or 8 requirements in the middle there? And it's like, oh, those got thrown out, but at least it's, you know, everyone can see it. So again, these tools are useful. I don't know if you guys use other things, but that's what's there. Professional tools that I see at big companies, especially Mil-Aero and medical, are things like doors, Polarion, and there's a couple different versions of doors, the original and the next generation. JAMA software I've seen some tools for. People use Jira, and I'd say that's used but not recommended. To me, Jira is better for task management and or issue tracking, not so much requirement tracking. Does that make sense? Because tasks and issues are a little bit different than actually just requirements. So the benefits to using any of these more professional type tools, and if you guys have more, I'd love to hear about them. If you know, these are the ones that I'm familiar with from working with companies. Are you getting a unique identifier for items? They totally handle all of your numbering of requirements for you. It's easy to share between stakeholders, like, hey, I made an update. You can have a lot of these systems, you can have like flags in there. So if anyone changes requirements, management gets an email saying where somebody changed the requirements, please go review again and approve, right? There's support for baselining and things like that. A lot of times, if you're at a customer and they're delivering like a medical device, they might have like life cycle support for this device. It gets approved, at least in the US, by like the FDA for so many years. And they have to be able to, in 3 years, if something happens, go back and say, well, that happened to that person, but during this test and our requirements verification, all this other stuff happened. So we're still good. We're still covered. You can't sue us for whatever happened, right? And so some of it's protecting themselves, but that is a lot better handled in some of these tools. And then they have a lot more reporting. So managing requirements in LabVIEW, though, there's one thing LabVIEW has, or not even really LabVIEW, but I guess National Instruments, and it's for traceability. So when people start talking traceability, again, this is usually regulated industries. I haven't seen this much at all with consumer electronics or automotive, but you've got change analysis. You want to know, why did things change? What requirements were overlooked? That's usually the biggest one. Did anything get missed? Project status, what could be reused between projects or other things, relationships between them, and then optimizing, like, can I do one test to prove out 5 requirements versus writing 5 different tests? And so things like that. And so the one tool that NI offers, this is actually kind of funny, but is Requirements Gateway. So we had a really hard question on Requirements Gateway about 6 months ago, and we contacted NI support. Everyone knows how well that always goes. And they're like, oh, we have an alliance partner who knows Requirements Gateway really well. Well, let us contact them and we'll get back with you. So one of our guys internally got a phone call from NI, and they're like, hey, this alliance partner. And we're like, wait, this is within our own company. We already asked him. You guys, what is going on? So it's kind of funny. Apparently the US, we have a couple people who have a really strong background in Requirements Gateway. They've written interfaces and things for that. So it's actually really funny to me that happened. But it's really sadly the best and only tool that's out there that's there. It has direct ties to LabVIEW and Test Stand. And then you can basically tie it into Word or Excel. This is the part that takes some backdoor work on your end. Like for our template, we've got stuff all built up, these interfaces. You can run Requirements Gateway, though. It basically scans our Word document for requirements, scans LabVIEW and Test Stand, and says, oh, you have this coverage here, or this requirement's met in 6 different places. I don't know why, but it is. Here you go. And it produces a bunch of reports you can look at. The disadvantages here, it's an additional tool. You end up with copies of stuff because you have like this copies into, like it scans it, and then it has its own copy of whatever the requirements were. And then it's scanning LabVIEW and Test Stand and having its own copy of where the requirements were met there. And then it's kind of got like outdated support. So it supports the original doors, but not the updated version of doors. It doesn't support any of the web-based tools that are becoming more and more popular. And so what other options are out there? What my co-presenter for this, and I left this in here because this is still really interesting to me. This hasn't really taken off yet, but I'm curious if anyone else is interested. Gerald Bitt, he works at OLMA Embedded Solutions, and he put together a proof of concept using OSLC, which I'll explain in a minute, to connect doors, but it could be other things. So it was just a proof of concept to show like the potential of doing it in LabVIEW and kind of figure out on his own, how much effort is it, and get community feedback. Is this something people want to see on the tools network? Is this something people are interested in? Or they really don't care about requirements and they're just going to do their own life. So what it is OSLC is an adapter layer, and I'll get into it in a minute, but the idea is you'd have the requirement management tools. You're using an open layer between the two to go direct to LabVIEW. He did not do anything with Test Stand, it was just LabVIEW. And this time, because OSLC is a web-based thing, You could also include things like Jira. So this is OSLC, is Open Services for Lifecycle Collaboration. I believe it was started by IBM, and it's an open community. It's part of OASIS. It's a standard, and it's kind of requirements management, architecture management, a bunch of things. But it's basically a standard saying, hey, everybody's got all these different tools for requirements, tools for writing software, tools for this. Shouldn't there be some universal layer so they can talk to each other? That's the whole idea behind OSLC. And so exchange references to artifacts, don't make copies, and provide reports or information. And the adapter he created had not a lot of maintenance. There was no intermediate copies, and you no need to learn a new tool. And so he's got a demo video in here that I'll just play. There's no words or text, but you can kind of see what's going on. Let me know if it's coming through on the screen. Sometimes things don't play well in PowerPoint. Can you guys see it? Thumbs up? Okay. So there's a couple parts. He has his OSLC adapter through the tools menu, and you have to basically choose from the DOORS database what modules. So he's got 2 requirements modules he's loaded in, a logging one and a measurement one. And then from there, he's got code that does things, right? And in here, he can right click, and he's got the OSLC adapter, and he can link it to a requirement, and it brings up this tool he brought up. And it basically is going direct to DOORS and saying, hey, what's in there? What's my requirements in that module? And once he selects it, I'll let him select it there. It'll actually be tied to there. So it puts a requirement and it puts it in there. So it ties it directly to there. So he's got a flag there for requirement. One of the things I recommended is that he actually add more information, like, you know, the requirement number or a little bit more details. But I mean, if you double click on it, it opens it back up. So maybe it's not necessary, right? But the other thing this does is he's got it set up so you can create a requirement in LabVIEW, and then it'll put it back in DOORS. So it's kind of a handshake. It goes both ways. So this was, and again, this is just an open standard out there. It's all web-based programming, but he created this kind of as a proof of concept. And I haven't seen any updates from him to see if there's been any changes, but they were using it internally on some projects just to see how it works. But he can link it to things. And then he can run reports and stuff when he's done. And so again, this is all something anyone could do themselves. He kind of did it as a starting point. If you're not using any of those tools, it doesn't make sense to, I guess. So quick summary, while we're wrapping up his video here, what format do you guys save requirements? If you do requirements, I'm curious, do you write them in like Word, Notepad, Excel? I'm just like, where's everyone stored at? You got Word, that's where we're at. Lots of Word, yep, Word, okay. GitHub, okay, so you got yours put in GitHub. Standard Word template, Excel. Ooh, DOORS is on the way, someone's getting an upgrade. The cum wrapper, napkin. Confluence, okay. And then the person using Confluence, do you link back to Jira for like testing things? Do you like link it back? Okay. Because we've done that a couple different ways. There's PTC integrity. Yep, we've got that at one of our customers. So Excel to define the requirements, and then you've got specifications, which are the Word documents. We have an interesting thing. We have what's our requirements are an official document in a template. Let me see if I can open something nice that's not hidden. Don't mind my mess on my computer. If I go into my templates, we're in the middle of changing our template folder, but this is our example template folder. And we normally have like engineering, PM, and then the code so it can go direct to Git. This is all in SVN right now. But in engineering, we kind of break up our work into specifications. And I call this my customer dump place, I guess. Is any document my customer gives me, I put in specifications. That's the stuff they gave me. Requirements, we typically have our normal template here, the system requirements. And not in here, but we have an Excel document. I think I have it in one of my other examples. I'd have to go back. One of the ones I was changing it. We have a test plan. And that may or may not be in here. And then we have verification. So we have multiple, this is something I'm in the process of improving, but our general workflow of a project is you have your specifications, requirements, design, develop. We've actually, This is more developed design documents. We used to have LabVIEW stuff in here, but we're currently hoping to move more from SVN to Git, I think, in the near future. We have both. We have projects in both right now. It's kind of fun. You know, I don't know which one I'm going to get. So we're in the process of improving it. And then verification and release is a lot of like PDFs or things we give to the customer. So I was interested in how everyone else does things. And this goes on for a long time. He just keeps showing. Now he's indoors, showing how it's linked or resolved and so forth. So I'll move on because I'm not sure if anyone would use that or not. But in summary, the big thing to me is that every project should use requirements, but the amount of detail in it's project specific. Some of our customers don't have as big of a budget, and to do a full-fledged requirements, you know, spend 40 hours writing requirements, reviewing them with multiple people is just not in their budget. Other customers, they do, but the key is you should have some sort of requirements. You shouldn't just write on the back of a napkin. And beware of language. Every project shall use requirements, not should. I'm saying shall. That means everyone on there has to do that. And you better prove it to me that you're using them. Write your test plan, your verification while you're writing requirements. So as you write a requirement, this is something, like I said, I work with our junior engineers on a lot, is they'll write a requirement and I'm like, how are you going to prove that you did that? How are you going to test that requirement? And they're like, oh, yeah, that's maybe not the best requirement. And so just keeping that in mind, or even writing your test plan while you're writing the requirements, is really helpful to have valid requirements. And remember, verification is not the same as validation, but both are needed. Select a proper requirements management tool. Sometimes this comes down to budget. Sometimes it comes down to customers. We don't have doors on site just because of the cost. Like, it's very expensive and not all of our customers would use it or want to use it. So it depends on what we're doing. Like I said, we tend to use just Word for our internal stuff and share with others as necessary. And don't forget about traceability. It's recommended, sometimes required, depending on your customer. Requirements Gateway is the default de facto tool. There's other options out there that people are starting to investigate. I'd be curious to hear if others are also interested in some of these other tools, or if people find good ways, because I think anybody in the LabVIEW community would love it, because we're always like left behind. You know, some of the other software tools, they get all the cool, fun stuff first. And then always don't forget, issue tracking is not the same as requirements tracking and tracing. So any questions? And I left this in here because if you want to get a hold of Jerabit, you should be able to email him. I mean, you can find him on LinkedIn if you're interested in what he kind of did with the OSLC layer there.
Thanks very much for that, Becky. That's awesome. It's good to,
no problem.
Good to see something a bit non-LabVIEW as well, to break it up a bit.
I know, I'm like, it's never that exciting, but it is kind of interesting to hear other people's takes on it. That's why I always like to hear, like, well, what is everyone else doing? I feel like we're stuck way behind the times using Word still, but I'm like, okay, everyone else is still using Word. I guess we're not doing that much worse.
Yeah, that's it. Yeah, because Word's just so easy and accessible, isn't it? And it's easy to share, and it has all those sort of benefits as well.
Save it as a PDF. It's just, you know, here it is. Everybody can get a copy. Everyone can read it.
Yeah, definitely. Awesome. All right. Anybody got any questions before we wrap things up? No,
it's Neil here. I'm curious. So, like, there's obviously a big investment into doing this properly, as you mentioned, Becky, like 40 hours plus. I think on a lot of smaller projects, it's just not done at all. Like, not even a Word document sometimes. Like literally, it's just what's in your brain. I'm curious what people use on like super small projects where it's like there isn't even, if it's just like one guy, you know, maybe a consultant. You don't have a requirements document. You know, you've got like a paragraph, an email, make this thing for me. Wondering what people do there. You know, I think that's quite common amongst like one-man band kind of things.
Now, what I've seen, there's a guy I'm friends with in Michigan. He's a alliance partner, but he's a single man shop. He always jokes he's the CEO, CFO, CIO, he's everybody, right? And he uses Excel. And it's interesting. I kind of like what he does just because it's his quick and dirty way, because those are the jobs he gets, are the ones that the customers might not have the budget for all those requirements. But he says he does it for his own sanity's sake. And it's kind of, he doesn't use ID numbers or anything, but the first column is kind of like a category. Is this UI? Is this like a analog input? Is this serial? He kind of gives it a category. Then he puts to the right like a sentence or two of whatever he expects or is planning to do. And then on the right-hand side, he kind of puts like demonstration or like test results or however he's going to test it to show the customer that he met that minimum requirement. And he said it takes him about 2 hours to throw together and maybe an hour to kind of go through with the customer and be like, hey, this is kind of my game plan. Here's the categories, the main things I'm working on. Here's my requirements. Here's how I plan to kind of show you that I met them. Any questions? And most of the time, you know, since it's a smaller job, they're like, yeah, that looks pretty good. Okay. Or other times he said, it'll be like, wait, well, I thought we were doing 485, not 232 or something like that might come up because everyone was talking cereal, but never said what flavor. Right. And so he finds that helpful for himself. But again, it's not fancy looking.
Sure. I guess you've got to be disciplined and do it up front. You know, if you get a week in and you've already got hardware and you're playing with it,
it's too late almost.
No one wants to put that aside to then start to look at this blank Excel document and to create it. Yeah.
And what's interesting is we had one of our Germany sales guys over in the US for the past year, and it was interesting talking to him because our sales cycle actually involves engineers. So a lot of times, like I'm involved in 2 different sales things right now, and I put together diagrams, I put together mock user interfaces, and this is during sales. And then that information sometimes gets put into requirements or design documents. So like stuff makes its way through because we want to make sure when we're quoting something that we're at least kind of more on the same page. So we almost start to write our requirements during sales, depending upon the job and how much we want it and how much we feel we understand there is there, right? If there's a lot of ambiguity in the job, we're like, ooh, let's toss together some rudimentary requirements to make sure we're going down the right path and coming up with the right numbers for in our head. And we've been pretty successful. It makes most of the jobs profitable, I'd say.
Yep. Okay. Thank you.